Okay, thanks very much. Thank you. I'd like to say that based on sort of the projections of what might happen if the Earth were to warm 2 degrees or 3 degrees, we could certainly agree that it's not really an experiment we want to run. On the other hand, there are other things that are sort of motivations for working on different sources of energy, and one is just the well-being of humanity. And if you plot sort of how well we do in terms of our medical services and our education versus how much energy we have, there's a very clear correlation. And another reason, apart from global warming and well-being, to work on things like renewable energy is simply air quality. It turns out that when there are events like major blackouts, like there was here in the eastern seaboard, where hundreds of power plants went offline in 2003, you can look at the air quality when all of these factories are shut down, and you can find that there's enormous reduction in very toxic chemicals in the air. So there are a number of reasons, not just global warming, although that's gotten a lot of attention lately, to work on new ways of making energy. Okay? So I want to tell you a little bit about that today and how nanotechnology is connected to that. This is how we have been using energy for the last 150 years. It turns out that a long time ago in the 1800s, we mostly just burned wood. And then we found coal, and coal is really cheap, but it's also really polluting, or it certainly was the way we used it back then. And so then we found this magnificent energy resource, which is oil and gas, which is what we all know and use today in our cars and our homes. It's an amazing chemical that stores energy very densely and very safely. So it's a really nice resource. But as we all know, we have a lot of issues with this, such as the emission of warming gases, but also the fact that these are not an infinite supply. If you look at the others, we take out nuclear because of national security issues and political challenges. We take out hydroelectric, which is this one, because it's pretty much tapped out worldwide, and we're left with this green sliver. And the challenge that we have is that we want half of our energy to be this green sliver by the year 2050. That's about what we need to do to keep CO2 emissions just constant. Not go down, but just to be constant instead of continuing to go up. Just to level them off, this green sliver has to be half of all of the energy we use by 2050. And you can see why that's such a challenge, because not only is it really small now, but look at this slope. It's going up, and it's going to keep going up. We're going to keep using more and more energy as a world community. So that's a really big challenge. Now, if you look at the resources that we have, just look at this country, and you say, well, where is this green sliver? Well, it's in things like photovoltaic cells, it's in wind, it's in biomass, and you look at where we have really good to excellent resources in these different green sliver energies, you see that we have lots of it. It's all over the place. We have great potential for solar cell energy here in the Southwest. We have wonderful places where we can get lots of wind and so forth. And the reason we don't take advantage of it, any of it really, to the extent that we could, is that these all cost too much. The ways that we make these energies cost too much. So we need huge improvements in their efficiencies and also big reductions in their costs. Now, one of the reasons why I like to focus on the sun is that if you look at the way the green sliver breaks down, we need about, let's see, we need it to be about 20 terawatts of energy, okay? You don't have to worry about what a terawatt is, but we need it to be 20. And if you look at what we could get from these different resources, this is about the maximum we could get around the whole planet, okay? But if you look at the sun, it's much, much larger. And in fact, the amount of energy that we get from the sun in 1 hour is enough to power the whole planet for a year, okay? For a whole year. So the sun is this magnificent resource. It's also something that if we just built solar cells, a very small amount of solar cells in Nevada, 150 square kilometers of solar cells in Nevada, we'd have enough energy to power a whole country, okay? And if we put these around the world in places where you get a lot of sun, which are these bright red spots, you'd have that magic 20 terawatts. The green sliver would be where it needs to be, okay? The problem is that this would cost $50 trillion to do today, okay? So that's what I mean by the fact that we just can't do it because it's too expensive. All right. Now, the thing is, and this is a very busy graph. All I want you to see is that we have the efficiency of solar cells versus the year, and you can see that they're all getting more efficient, but they're way too expensive. And what's really exciting are these ones down at the bottom here. They're really inefficient, okay? But they're getting more efficient. And what's interesting about these is that they're based on nanomaterials, so they cost much less money to make, okay? Because you can make them with very simple wet chemistry processes. So I want to tell you now a little bit about nanotechnology and what it is, and then a little bit more about how it can play a role in energy and in solving some of these problems that we face with energy. We've used nanotechnology for millennia without knowing it, because nature uses nanotechnology all the time. The frog hears by having a little cantilever in its ear that moves a few nanometers back and forth. Silk moths, a male can sense a female silk moth 2 miles away. The reason is that it has a little nanomechanical sensor that can detect a single pheromone molecule. And ants use nanotechnology in their eyes just to see a little bit better. So what we want to do is we want to try to follow what nature's been doing for a long time and be able to utilize some of the things that happen. And I want to tell you why that's so exciting. To put it into context though, I think the person who first sort of thought of this idea of using nanotechnology was someone named Richard Feynman, where he gave a very famous speech called "There's Plenty of Room at the Bottom." And he said it would be in principle possible for someone to synthesize any substance that the chemist writes down, put the atoms where the chemist says, and you make the substance. So you build things up atom by atom. That was his idea. And in fact, what happened was 30 years later, we actually were able to do that. We were actually able to take atoms, these are just single atoms, and move them around on a surface and spell things like the logo for a company, for example. Okay? We've also had a very important debate about the toxicity of nanotechnology and the potential health benefits or hazards, and I don't have time to go into that, but I want to mention that this has been a really important part of the evolution of nanotechnology research. And it was started by sort of a book that was written in the 80s by Eric Drexler. And finally, President Clinton started a national investment in nanotechnology. It's called the National Nanotechnology Initiative. President Bush increased that, and it's now at a very substantial amount of over $1 billion a year. And that has sort of really helped to make this whole field go forward. So if we ask Google what nanotechnology is, and we all know Google will just tell us the answer, right? We can say define nanotechnology. It says, well, it's sort of somewhere between 1 to 100 nanometers of material to create new structures. And then the next bullet says it's between 0.1 and 100 nanometers, and the one after that says less than 200 nanometers, and the one after that says less than 1,000. And I like this. Then he says it was first coined by Drexler in '86, and right under that it said it was coined in 1974. So what is nanotechnology, right? How do we define it? Okay, so Google is having trouble, so we turn to the press. And this is my favorite article about nanotechnology: how super cows and nanotechnology will make ice cream healthy. And the way they define it is also experimenting with nanotechnology, or the science of invisibly tiny things, which I find a very nice definition. So let's move away from the press. How about marketing? Well, nanotechnology is in your tennis rackets now, and this is hard to see, but it says that it's a study of the scale of the atom. Okay, that sounds interesting. And we know Hollywood gets things right. So this is nanotechnology in Hollywood. Actually, if some of you may know that Spider-Man's first nemesis was a nanotechnologist, and that the Incredible Hulk was made by nanotechnology. And then finally, I moved here recently from Berkeley, California, and this is how they define nanotechnology. And so they protested a lot, but what's funny is that they're actually quoting Feynman's speech on their back. Plenty of room at this bottom. But what's interesting is they're actually not protesting nanotechnology, they're protesting GMOs. But in any case, so that's another point of view. And we can always look to the government for help. And actually, this is a really nice website, and I encourage you all to look at it. If you go to nano.gov, you get beautiful pictures of things made by nature and things made by people. And you compare the size scales with such charts. It's a very interesting, actually, set of examples of nanotechnology.